Hi, my name is Eric Hankey, and I am Principal Engineer of Storage and Memory Products at IntelliPrep. Today, I'm going to be walking through a demonstration of the life cycle of pooled memory using the IntelliPrep CXL fabric adapter. I'm going to show you the small fabric topology that we'll be running for today's demo on the next slide, but what we'll be doing in the demo is allocating a portion of the fabric attached memory resource to two separate hosts. I'm going to perform a small workload on that fabric attached memory and then release the fabric attached memory resource back into the pool such that it can be used by another host in the future. So here's the fabric topology that I'll be running the demo on today. I have three separate host nodes, two ARM-based nodes, and one x86 Intel Sapphire Rapids CXL host. The primary fabric manager runs on one of the ARM nodes. Then I have another ARM node and this CXL1 node consuming the fabric attached memory resources. Also in the fabric, I have two separate switches and two ZMMs or fabric attached memory nodes that each have a capacity of 128 gigabytes. So if you're interested in a little bit deeper dive on the setup and the conversion of DAX devices to NUMA devices, I will link to another video demo that I did in that space at the end of this video. So now I'm going to jump in to the demonstration. We have a grid of terminals here. On the upper left-hand corner, we have our Zephyr Fabric Manager running. In the top middle, we are connected to the SoC4 running HTOP. Top right, we are SSH'd into the CXL1 host. And then we're going to be running some workloads from these middle terminals, also SoC3, SoC4, and CXL1 from left to right. On the bottom left-hand corner, I have a graph that will show real-time packets per second that are being sent to one of the fabric attached memory devices. In the bottom middle, I have a bar graph that's showcasing the current allocation of fabric attached memory resources. So in the leftmost column, this green bar represents the local memory that is connected to the CXL1 host. Same for SoC4 and SoC3. So this is just green represents local, blue represents fabric attached resources. So in the lower right-hand corner, you can see a simple fabric topology that's being drawn based on what was found by the fabric manager during discovery. And I can show a text version of that topology by running the ls gen z utility. And here we can see all of the different components, the fabric switches, memory devices, bridges, and such. Okay, so as you can see in the multi-host memory allocation graph, all of the memory pool is unallocated. And it's just sitting there ready to be allocated to a particular host. So the first step in this process is we're going to dynamically allocate a portion of that memory pool to SoC4 and CXL1. To do that, I'm going to run a utility called post Zephyr res. The first allocation that I'm going to do is a 60 gigabyte allocation from ZMM 0 to the SoC4. Now over here, I can run lstopo and see that sure enough, we now have a roughly 60 gigabyte chunk of memory that is in DAX mode. So to get it to show up in our multi-host memory allocation bar graph, I'm going to have to take that DAX device and hand it over to the kernel. So I'm going to do that with this DAX to NUMA utility that we created. And while this is running, you can see that we're getting some packets that are showing up to the ZMM0 from SOC1 as it's initializing the kernel memory. Another thing to notice is up here, you can see the memory size growing as we complete this onlining process. So it started out as 4 gigabytes, and now we're seeing an HTOP roughly 64 gigabytes of memory. And once that allocation completed, you can see out of the pool of memory, we're now seeing in SOC4 a portion of the memory being local RAM, and a portion is fabric attached memory. And I can run NUMA control to see that. I have roughly 4 gigabytes of local memory and roughly 60 gigabytes of fabric attached memory in NUMA node 1. Okay, so that was the first allocation. Now we're going to do another allocation to our CXL host. And so now I can run lstopo over here and see for the CXL host, again, we have a 60 gig DAX device. And now I'm going to take the DAX device on CXL1 and hand that over to kernel memory using the DAX to NUMA command again. And while that's running, you'll also see some packets that are showing up. Okay, so now we have memory that's been allocated over to the CXL1. We have fabric attached memory that's on the SOC4, and you can see roughly half of the memory has been allocated out of the memory pool. So now I can do things like this. So I can run some workload on SOC4. And what's happening here, you can see the traffic is going out to the ZMM is I'm running a mixture of memory interactions with local hosts memory and remote host memory. This one is remote only. And when that finishes, maybe I'm done with that memory, I can return it to the pool. So if I run this lsmem, I can see the blocks that are being used for that 60 gigabytes of online memory, and I can remove it now. And I can do so by running this chmem command. Okay, so now we'll see these SOC4 memory go back into the memory pool, and I can run lsmem again and see that we have back to 4 gigabytes of online memory. Okay, so now I'm going to remove that DAX device, because if I look, so I am going to take this UUID that we got when we ran the allocation initially, and now I'm going to do a remove. So now that memory has been completely removed from the device. So you can see I can't, there's nothing, no device, no DAX device any longer showing up to SOC4. So I can do similar things over here. I see the 59 gigabytes of online memory. I'm going to remove that with the chmem command. Once that memory is disabled, it'll show back up in the memory pool column. So this is a quick life cycle of pooled memory, how to allocate dynamically online, use that memory, and then deallocate that memory when it's done being used. Hopefully that was informative and helpful. Do please let me know if you have any questions I will put my email address down here and the Intelliprop website that you can learn some more about some of the things that we're doing in this space. Thank you very much and have a great day.